Hi everyone, so now we're going to be talking about mutually exclusive events. Mutually exclusive events are slightly different than independent events because mutually exclusive events are two or more events that cannot occur at the same time. So there is no version of them happening at the same time. Independent events can happen at the same time. Mutually exclusive events cannot. A good example of a mutually exclusive event would be flipping a coin. So when you flip a coin, you can either get heads or tails, but you cannot get heads and tails. So those two things would be that the probability of getting heads and tails is 0. So there's no version of getting both of them together. The way that we can tell mutually exclusive events with formulas are the two formulas right down here. So the first formula is the probability of A and B is equal to 0. This makes sense because if we use my flipping the coin example, the probability of getting a heads and a tails, there's no version of that, so the probability is 0. The other equation is the probability of A or B is equal to the probability of A plus the probability of B. So on this one, if we use my heads and tails example, we're saying the probability of getting a heads or a tails would be the probability of getting a heads plus the probability of getting a tails. So in a coin flip, what's the probability of getting a heads? Well, the probability of getting a heads is 1/2. I'm going to write this in a different color just so we can see. Let's see. So the probability of getting a heads is 1/2. And let's say the event B is the probability of getting a tails. Well, the probability of getting a tails is also 1/2. So if I do 1/2 plus 1/2, I get 1. So the probability of getting a heads or a tails is 1, or 100%. And this makes sense because there's no way that you can't get heads or tails. There's no other option. There's only two options, two sides of the coin. So there's a 100% chance that you're going to get heads or tails. So these are the two equations we can use to determine if something is mutually exclusive. Now, there's another option for it to be non-mutually exclusive. And non-mutually exclusive events are events that can occur at the same time. So a good example of this would be like if you have a deck of cards, you can have a red card and you can have a face card at the same time. Like there's such a thing as a red queen. So those are non-mutually exclusive events. Whereas like in my deck of cards, mutually exclusive events would be getting a black card and getting a red card. Well, there's no black and red card, so those are mutually exclusive, but getting a black card and a number card would be non-mutually exclusive because you can get that at the same time. There is a black number card available. So the formula that we can use to determine, or if we know that something is non-mutually exclusive, then we can use the formula probability of A or B is equal to the probability of A plus the probability of B minus the probability of A or B to determine any missing probabilities that we have. So now let's start going through some examples. For the first example, what we want to do is determine if the events are mutually exclusive or non-mutually exclusive. So in order to do that, we can use one of the formulas, and I'm going to end up using the formula, the mutually exclusive formula. I'm going to underline it right here. This P A or B is equal to P probability of A plus probability of B. The reason why I'm using that one is just because they've given me all of these values. So when I use this formula, I'm going to plug in the values for where they go, and if the left side is equal to the right side, or if the equation makes sense, then I know that it's mutually exclusive. If the equation doesn't make sense, or if the left side is not equal to the right side, then they would be considered non-mutually exclusive. So let's start with probability of A or B, which they tell me is 4/5, is equal to the probability of A, which is 1/4, plus the probability of B, which is 11/20. So now what we need to do is figure out if the left side is equal to the right side. So when we add fractions, they need to have this same denominator. We're going to add 1/4 and 11/20. So I'm going to multiply both the top and the bottom of the 1/4 by 5, which gives me 5/20 plus 11/20. Now that they have the same bottoms, I can just add the tops. 5 plus 11 is 16, so it's 16/20. But I can simplify that by dividing each chunk by 4. 16 divided by 4 gives me 4. 20 divided by 4 gives me 5. So now I have this equation that says 4/5 is equal to 4/5. That makes sense. The left side is equal to the right side. And because the left side is equal to the right side, that tells me that these events are mutually exclusive because they fulfilled the mutually exclusive formula. If they didn't, then they would be non-mutually exclusive. Okay, now let's look at the second example. And on the second example, it says find the missing probability given events A and B are mutually exclusive. So again, sorry, let me scroll up a little bit. We're going to use that same formula that I underlined in red because we're assuming that they're mutually exclusive. So we're going to have to use one of the mutually exclusive equations. And we have enough information that we can use the bottom one. So I'm just going to rewrite that equation here. So the probability of A or B is equal to the probability of A plus the probability of B. And then let's just plug in what we know. So we know the probability of A or B is 2/5. And that's going to be equal to the probability of A, which is 1/5, plus the probability of B, which is what we don't know. So I'm going to leave it as probability of B. Now to solve this for probability of B, what I'm going to do is subtract 1/5 from each side. So the 1/5 get canceled out right here, and now I'm left with 2/5 minus 1/5 is equal to the probability of B. In order to add and subtract fractions, they need the common denominator. They already have a common denominator in this case, so we just subtract the tops. 2 minus 1 is 1, which means the probability of B is 1/5. And that's how we find it. And that was because we used the mutually exclusive formula because they told us that the equations were mutually, or because they told us that the events were mutually exclusive. Now for the third example, it says find the missing probability given the events A and B are non-mutually exclusive. So we're going to have to use the formula, this formula right here that I'm going to underline in red, because that's your non-mutually exclusive formula. I'm just going to write it down under this example number 3 so we can see it a little bit better. Probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. Okay, so I have a bunch of information here. All I have to do is plug in what I know and then solve for what I don't know. So probability of A or B, they tell me is 53/100. And then that's going to be equal to the probability of A, which is 1/5, plus the probability of B, which is 2/5, minus the probability of A and B, but we don't know that one. That's what we're trying to solve for. So I'm going to leave it as probability of A and B. The first thing I'm going to do is add 1/5 and 2/5, so I get 3/5. I can write it as 53/100 is equal to 3/5 plus, or not plus, let's say minus the probability of A, oh, sorry, not or, ooh, making so many mistakes, and B. And then to solve this, what I can do is subtract the 3/5 from each side. So basically we'll have 53/100 minus 3/5 is equal to negative probability of A and B. So I'm going to figure out what 53/100 minus 3/5 is. That's going to give me a negative number, and then I can just take the negatives out of both sides. It'll give me a positive probability still. So 53/100, I'm going to change the 3/5 to be over 100 by multiplying the top and the bottom by 20. I'm going to kind of go over here. So I would have 53/100 minus 60/100, which gives me negative 7/100. And that's equal to the negative probability of A and B. Because they're both negative, I can take the negatives out, which means that the probability of A and B is just equal to 7/100. All right. Okay, the last example here says determine whether the scenario involves mutually exclusive events, then find the probability. So the first goal is to decide if they're mutually exclusive or not. So let's read the question. It says there are 5 nickels, 4 dimes, and 3 quarters in your pocket. You randomly pick a coin. It is a nickel or a dime. So to decide if these are mutually exclusive or not, we need to kind of go back to the definition of mutual exclusivity. And remember, that definition is when two or more events cannot occur at the same time. So we want to think about this. We want to pick a nickel or a dime. Is there any version of us, or is there any event where we can pick a nickel and a dime at the same time if we only pick one coin? No, because you either pick a nickel or you pick a dime, right? There's not a nickel dime hybrid. And so because I can either pick a nickel or a dime, I can't pick both. These are considered mutually exclusive. So I'm going to write mutually exclusive. Now, if it asked me to pick two coins and said, okay, you can pick a nickel and a dime, or you can pick a nickel and a quarter, those things wouldn't be mutually exclusive because you could potentially do that. But because you're only picking one coin, you can't pick both a nickel and a dime, or a nickel or a dime. You're only picking one thing. So these are mutually exclusive. Because they're mutually exclusive, we can use the formulas for mutually exclusive events, and that formula is that the probability of A or B is equal to the probability of A plus the probability of B. Now, let's say that our event A is picking a nickel, and then our event B is picking a dime. So if I want to pick a nickel, remember, probability is what I want divided by the total. So there are 5 nickels, and that's what I want. And then the total amount of coins is 12. So the probability of picking a nickel is 5 over 12. The probability of picking a dime would be, again, what I want, which is dimes, over the total. So there are 4 dimes, and then there's 12 total coins. So to find the probability of picking a nickel or a dime, or the probability of A or B, which is what I want to find, that's equal to the probability of A, which would be 5 over 12, because that's your probability of picking a nickel, plus the probability of B, which would be 4 over 12, because that's the probability of picking a dime. And now all we have to do is add those things together. They already have common denominators because I didn't simplify anything. So 5 plus 4 is 9. That's over 12. Those can be simplified by dividing each chunk by 3. So 9 divided by 3 is 3. 12 divided by 3 is 4, which means the probability of picking a nickel or a dime is 3/4. So you have a 75% chance of picking a nickel or a dime out of your pocket. And there we have it, mutually exclusive versus non-mutually exclusive events.